Hello everyone, I am Shankha Subra Sanyal and I am today over here with the sixth lecture of the series. We have given you around 5 worksheets. These 5 worksheets we have close to 50 questions. In this sixth lecture, what I'm going to do is I'm going to discuss with you the answers, the probable answers I would say to those questions. What we'll be doing is we'll be taking up worksheet one by one and then we'll be carrying on with our discussion. My suggestion is before you listen to this video, what you should do, you should keep your worksheets ready with you. They should be handy so that the moment I discuss a question, you can refer back to the answers that you have written to the questions of these worksheets. Sure? So let's begin this session. Let me begin with worksheet number 1, which was given on the first day. The first question is, how is sound produced? Well, by now you are all aware the sound is produced by our body, which is vibrating. So vibrations produce sound. The next question is, give any 4 sources of sound in a marketplace. Now, when you go out in the market, we come across a lot of noises, lot of sounds. Now these may be some of the sounds might be pleasant to hear, some of them are really irritating for you, but then they are all sources of sounds. One such source is the honking of the horns by the scooters or maybe by the buses. Another one could be the loudspeakers that are there. There could be loud music being played from the stereo system. There may be chirping of birds. People who are riding on bicycles, the bells of the bicycles have some sounds being produced from them. So these are some of the examples that you can cite. Any relevant other example that comes to your mind, you can always do that. Which part of our body vibrates when we speak? Well, it's the vocal cord. So the vocal cord is what vibrates when we actually speak. That means the answer to this will be the vocal cord. Define amplitude of a wave. Now, what is amplitude? Amplitude is the maximum displacement. What is it? It is the maximum displacement of the particles in motion. From where? From its mean position. So if I need to define you what is amplitude, I would say amplitude of a moving particle is the maximum displacement on either side of the mean position. So this is what I would call as definition for amplitude. Name the physical quantity whose SI unit is Hertz. Well, Hertz is something which is related to frequency. So the physical quantity over here, the answer should be frequency, right? Name the 2 different types of waves. Well, the 2 different types of waves, if you see video number 1 over there, we have discussed in details about transverse wave and longitudinal wave. So these are the 2 types of waves. Sound waves consists of places of high pressure called dash and places of low pressure called dash. This is a fill in the blanks. Well, high pressure is when the particles are close together. That's what we call as compression. And when the particles are away from each other, they are known as what? They are known as rarefaction. So the answer to this would be compression for the first blank and rarefaction for the second blank. What is the relation between time period and frequency of an oscillating body? Now check this out. Time period and frequency. Is it related by some equation? Yes. What is that equation? We have called it as wave equation, right? But before the wave equation, I told you that frequency and time, they are inversely related to each other. That means frequency is equal to 1 by time period, right? So the question that is over here, what is the relation between time period and frequency of an oscillating body? The answer to this should be F is equal to 1 by T, or they are inversely proportional. State the wave equation. Just now I was discussing about this. Now wave equation is what? V is equal to lambda by T, or V is equal to lambda F, where lambda is the wavelength, V is the velocity of the wave, and F the frequency, right? The last one, the 10th one, a pendulum makes 150 oscillations in 5 seconds. So how many oscillations it makes? 150 oscillation. And what is the time given? 5 seconds. What is the frequency of the pendulum? Now if you put it in the wave equation, you can easily solve it. For your benefit, what I'll be doing is just go for the next slide. On this screen, I'll be solving this question for you. Sure? Now, in 5 seconds, the pendulum will make 15 oscillations. So, in 1 second, the pendulum will make 15 by 5 oscillations or 3 oscillations. Thus, the frequency of this pendulum is 3 oscillations per second, or 3 Hertz. Well, something which is noteworthy over here is the frequency is very low and it can't be heard by our ears. Let us discuss now about the questions that are given in worksheet number 2. To begin with, the first question is, what should an object do to produce sound? Of course, it needs to vibrate. Can sound travel through vacuum? No, it cannot, because it's a property that if sound needs to travel, it needs a material medium. And in vacuum, you don't have any material medium, so sound cannot travel. Name one solid, one liquid, and one gas through which sound can travel. See, at the beginning of the lecture, I said I don't want to, limit your thought process. The answers that I'll be giving you will be the probable answers. And for this question, we have a variety of answers that you can come up with. But let us confine ourselves to the general ones. But again, you can always go down. The first one is, name one solid. Well, it should be steel, liquid, water, and the third one is gas, air. These are the three mediums through which sound can travel. In which medium sound travels faster, iron or air? Of course, sound travels faster in iron. With reference to musical instrument, name any 4 methods by which sound can be produced. Well, sound can be produced by stringed instruments like guitar, sitar. It can also be produced by membrane instruments like tabla, dholak. It can be produced by air instruments like flute, mouth organ, or it can be produced by metal plate instruments which are known as Campbell's and all. The sixth question it says is, how do astronauts talk to each other in outer space? As I have just mentioned that sound cannot travel in vacuum. This is a very important concept. So astronauts cannot talk to each other using the method me and you can interact with, because over there is no particle medium. So what we actually need to do is, when astronauts are in the outer space, they use radio waves, because they are electromagnetic waves and they can communicate easily through this electromagnetic wave through walkie-talkies. What brings the sound of a ringing telephone bells to our ear? Yes, that's air, because between the telephone and my ears, what is present, the medium is air, so it's air which brings it. What name is given to the aircrafts which fly at speeds greater than the speed of sound? Well, what could be the answer for this? Supersonic aircrafts, or in common language we call it as jets. So that could be the answer. In the rainy season, why the flash of lightning is seen first and the sound of thunder is heard a little later? Well, again, it has been quite well. I have discussed about this in lecture number 2. So what you can do is you can refer over there for the exact values. But my answer to this question would be because of the difference of speed. And it is because of the difference of the speed. When you watch a live cricket match, you would find that there is a difference in hitting the ball and hearing the sound. The sight and vision does vary over there. Explain why a ringing bell suspended in a vacuum chamber cannot be heard outside. The answer lies in the fact we have already discussed, because sound cannot travel through vacuum. So if your ringing bell is kept inside a bell jar where the air has been sucked off, so what you are left with? You are left with vacuum. In a vacuum, sound cannot come out, right?